Okay, welcome to Redzone number 12. We're almost done with the red zones. We've covered almost every single topic that we've done this year. And the goal of this is to make the transition to high school math, to algebra, a little easier on you. This is something we do in school, even if we were there physically learning in a classroom. We feel like we want to go over the major topics that we know you're going to see again in high school. So Red Zone 12 is all about volume. You will see volume again in 9th grade algebra and again in 10th grade geometry. But before we get to volume, the first question on this red zone is just a little bit of a review question. So it says on the coordinate plane below, rectangle ABCD is rotated 90 degrees clockwise about the origin to form rectangle WXYZ. Now normally they would use letters like A prime, B prime, C prime, and D prime, but they chose to use just 4 completely different letters, which they can do. And they want to know which statement about the relationship between rectangle ABCD is true. You're going to get questions like this when you get to 10th grade geometry. And the main thing you want to do here is make sure that they are matching up the correct letters. And a good trick you could do is you can write down the letters of the shape in order on top of each other. So you can see that A matches up with W, B with X, C with Y, and D with Z. And that helps me because if I'm talking about side AB, which is this side right here, without even looking at the shape, just looking up here, I can see that A and B match up with W and X. And that would be this side right here. So just by writing these letters on top of each other here and seeing which letter matches up with which, that's actually going to help us answer this question. But before I look at the answer choices, I just want to remind you that when we rotate, you can rotate things clockwise or counterclockwise. This one was rotated clockwise. That's why we started here in quadrant 2 with ABCD, and we rotated it clockwise, and you can see that it ended up on its side in quadrant 1. And that's exactly what rectangle WXYZ looks like, right here on its side in quadrant 1. So let's take a look at the choices, and as we look at them, I'm going to keep referring to these letters here to see if they match up properly. So first it says that side DA, which is this long side right here, matches up with side YZ. I can see in the diagram that that is absolutely not true, but I can also see that DA does not match up with YZ. The letters are not matched up correctly, so that is incorrect. B, it says, oops, got to get rid of those lines. Choice B, side length DC matches up with XY. Again, clearly those are not corresponding sides. You have to look at it, after I rotate this one, where does DC end up? And that is not where it ends up. And if you look at the letters, DC does not match up with XY. So again, choice B is incorrect. So we crossed out A, we crossed out B. Choice C says BC, this long vertical side here, matches up with YZ. No, that's a long side and a short side. The letters don't match. And it says AB corresponds or is congruent to WX. Well, they look to be the same length. They're both 3 boxes, but let's make sure that they also have the correct letters. AB would be right here, and WX is right here. Matches up perfectly. Okay, let's talk about volume. Volume in math, and when you ask what volume is, I don't want to hear you guys say volume equals length times width times height. That is a formula for volume of a very specific shape, but in general, volume is the 3-dimensional space that an object takes up. So if you think about it, we live in a 3-dimensional world. Everything around us is 3 dimensions, and certain objects take up more space than other objects. That's volume. So if I wanted to fill a storage unit, I might need to know the volume of everything I'm putting in there. If I need to put in 2 dressers, a mattress, 3 couches, a bike, all this stuff, I need to take volume into account. Another way to think about volume, and this is how you see it more often, is how much fits inside a 3-dimensional object. So if you look on a label of a water bottle that you're drinking or a Gatorade or something, it tells you how much volume that bottle has, how much water or liquid fits inside that bottle. So in 8th grade, we talked about 3 different shapes when it came to volume. We briefly mentioned rectangular prisms just to go over it again, but the three shapes we concentrated on in 8th grade were cylinders, cones, and spheres. And there was two ways to write your answers to a volume question. One was as a decimal, and you round it. They tell you to round to the nearest tenth, or the nearest hundredth, or whatever they told you to round to. The second way we learned how to write our answer was in terms of pi. So that would mean that the answer has the pi symbol in it. So for example, if I wanted to find the volume of a cylinder, maybe it comes out to 211.43 cubic centimeters. But if I want to write it in terms of pi, and I don't know this off the top of my head, but maybe we write it as 68 pi. Those are the two different ways to write your answer. We'll go over both of those in this red zone. So now, well, let's go over them right now, actually. So here's a cylinder, and there's two main measurements of a cylinder that we're going to focus on for volume, and that would be the height. That's how tall the cylinder is. And it doesn't matter if this cylinder was taken and turned on its side. That's still considered the height. And then the radius. The radius is a line that goes halfway across the circle that makes up the base of the cylinder. You need the radius and you need the height. Sometimes they will give you the diameter. No good. You need to cut that in half and find the radius, because the volume formula for a cylinder is pi times whatever the radius is squared times the height. Pi radius squared will find us the area of the circle, and then we just have to multiply by how tall the cylinder is. So let me put some numbers on the cylinder so that we can do a practice problem and you can see how the formula is used. Anytime you use a formula in math, the first thing you need to do is write down the formula, then substitute in the missing variables, and then solve for whatever you're looking for. So let's say that the radius is, I don't know, I'll pick an easy number. I'll just put 4. And we'll say that the height is 10. And I'll say it's inches, but it doesn't really matter because it's an example. So now I substitute in volume equals pi times 4 squared times 10. Now, if you have a multi-view calculator, you can go straight to your calculator here and just plug that in, and your calculator will give you the answer in terms of pi. If you don't have a multi-view calculator, if you were using the calculator on your phone, on a computer, or you have a different scientific or graphing calculator, it's going to give you a decimal. So we need to talk about that. First, let's get our answer as a decimal. So I pull up my calculator, which I have here, and I think you guys can see it, and it said that it was pi times 4 squared times 10. And this is the calculator you're going to have next year, or something similar to it. I just have it on my computer, which is why it looks like this. I hit enter, and there's my answer, 502.6548. So volume equals 502.6548. And if you have the multi-view calculator, you can hit that double arrow button, and that'll go back and forth between terms of pi and a decimal. Now, if this said rounded to the nearest tenth, for example, we would round this to 502.7 cubic inches. So that's decimal. But what if I wanted this in terms of pi? Now, some graphing calculators do not give it to you in terms of pi. As you see here on my screen, if you have the multi-view, it does. So the way you get in terms of pi, if you don't have one of those fancy calculators that does it for you, is I'm going to enter this in my calculator, but I'm not going to put pi in. I'm just going to put 4 squared times 10. And that's going to give me 160. So this is what the answer is before I multiply it by pi. So my answer is 160 times pi. And I just read that as 160 pi. This and this are the same exact answer. They just look different. We like to use this one in math because it's cleaner and it's more exact. This answer is a decimal, and we had to round it, so it's not quite exact, but it's very close. So those are the two different ways that we can write our answer. Now there's 3 types of questions you're going to see. Let me put up the screen shades. I go one by one. First question is straightforward, like the one we just did. They give you a shape, you write down the formula, you use the formula, that's it. The second type of question is a composite object. That's when there's 2 objects together. So for example, we might have a cylinder with a cone on top of it. Well, that's 2 objects. So you're going to have to find the volume of the cone, find the volume of the cylinder, and then add them together. That's the second type of question you're going to see. The third type of question is when you have a composite object that's missing a piece. So for example, I might have a cylinder, and maybe they cut out a cone from the top of it. So then I need to find the volume of the cylinder, I need to find the volume of the cone, but then I need to subtract it because they're taking away the cone. So we only want this part. So whenever you get to a shape where they're cutting out an object or removing an object, you have to use subtraction. And then the third type of question you're going to see is when they give you the volume of an object and you need to find one of the missing parts. So if we go back to that cylinder and they tell you the volume of the cylinder is 160 pi, the radius is 4, and we don't know the height, that's the fourth type of question when we're looking for one of the measurements. All right, let's jump into these questions. We'll go through them, and then you can reach out with questions or join us live. Okay, so already when I look at this, even before reading it, I kind of notice that there's two objects here. There's definitely a big cylinder, and then at the top, there's this circle with this like triangle looking, that's a cone. It's a very small cone, but it is a cone. Sorry, there we go. It is a cone, so we're gonna have to, this is a composite figure. The object below is made of solid plastic. It is a cylinder with an indentation at the top in the shape of a cone. Indentation means like a cutout, which means that it is missing. So at some point, we're going to have to use subtraction. They're not adding two figures together, they're cutting out one of the figures. What is the volume? To the nearest tenth of the plastic object. So not in terms of pi, we are rounding everything. So we're going to use our calculator to give us decimals. So if I want to write out the steps of what I need to do here, first I need to find the volume of the cylinder, the whole big object. That's where I need to start. Then I need to find the volume of that cone at the top, that indentation, that part that's missing. And then once I find those two volumes, I need to subtract. Here's a note for any time that you are rounding answers in math of a multi-step problem. Try not to round your answers until the very end of the problem. In this question, it won't really matter because the four answer choices aren't very close together. But what if the four answer choices were like 104.4, 100.3, 97.6, and 97.5? Then they're so close together that you don't want to mess up rounding. So don't round until the very end of a question. Okay, so let's find the volume of a cylinder here. I'm going to switch colors. So volume equals pi times radius squared times height. These formulas are provided for you. Let's see, pi is pi. The radius they don't give you, but they do give us the diameter. And we know that the radius is half of that. So that would be 2 squared. And the height they give you very clearly is 8. So I now go to my calculator and I do pi times 2 squared times 8, just like I wrote it on my paper, and I get 100.5309. I can round it, just not all the way to the 10th place. I'm going to round it to 100.531. 100.531. Okay, that takes care of that. Now let's switch colors and do the volume of the cone. This one's a little trickier. So the volume formula for a cone is 1/3 pi radius squared height. Let's start filling in what we have. 1/3 pi. Let's take a look at the radius. Well, they don't give us any information up here, but that circle is the same exact size as the circle at the bottom. So it actually has the same radius as the cylinder. So we're going to stick with 2 squared. And the height of the cone is not 8 inches. The height of the cone is only this little bit right here, which they give us. It's 0.7. So the height is 0.7. I go to my calculator, and it's, oops, I think there's a way. Yep, on this calculator, the newest ones, there is a way to write fractions. Some of them do not have that. 1/3 pi 2 squared times 0.7. And I get 2.932. 2.932. And then my third and final step that I wrote down ahead of time, which is the solve strategy. is to subtract. So minus 2.932, 100.531. Oh, it's right here. It's right here for me. So actually, I think I can go up to that, click enter, and then do minus, go up to that, and click enter. So you see how I was just able to get those exact numbers, and I don't have to worry about rounding. My calculator is handling this for me. One thing I can advise for 9th grade, learn how to use your calculator. Even if your teacher isn't showing you every day, what you can do in this, go home and Google how to do blah, blah, blah on the calculator. It will help. And you get 97.5988. So you get 97.5988, which is rounds to 97.6. Next question, what is the volume in terms of pi for a cylindrical container with a radius and a height? This is a straightforward question. The part of this question that is not straightforward is how they write their answers. Notice that all 4 answer choices are in terms of pi, but they also have decimals. That is going to give your calculator a hard time. So let's take a look. It says cylindrical container. That's a cylinder, so volume equals pi times radius squared times height. We can just fill in that information. Now the problem we're going to have here is because 3.25 is already a decimal, your calculator, your multi-view calculator, is not going to want to give you the answer in terms of pi. When there's already a decimal involved, it doesn't want to do it. So you have to know how to do it. So I will show you. So I go to my calculator, and I'm going to show you how to write it as a decimal and in terms of pi. If I want it as a decimal, I just type in this whole thing right in my calculator. So that would be pi times 3.25 squared times, and I believe the height was 10. I need to double check. Yes. And I get this, 331.83. Now, if you're too fast, which a lot of you are, because we did this question this year, and most of you picked the wrong answer. Not because you didn't know how to do this topic. You knew how to do volume. You knew how to write the formula, plug in, and use your calculator. But what you don't know how to do, and this is where many students struggle, is to slow down and make sure your answer is in the correct format. That's the E part of solve that you guys hate. Evaluate your answer. This says 331.83. This says 331.83 times pi. Those are 2 very different answers. So what you could do is you can multiply each one of these answers by pi and write down what they are as decimals and then see which one comes out to that. Or you can use your calculator to give you the answer in terms of pi. So remember, to get an answer in terms of pi in a calculator, you only put in the numbers, not the pi symbol. So I'm going to write 3.25 squared times 10. I'm leaving out the pi that I entered in the first time. And it's going to give me 105.625. 105.625. But remember, I didn't put in the pi, so I have to leave it in my answer. These 2 answers right here are both correct. They're both the exact same thing. This one is a decimal, and this one is in terms of pi. All of these answers are in terms of pi, so we want this one, choice B. Also, if you pick up your calculator, which I'm about to do and show you, and I do 105.625 times pi, and I hit enter, look at that. It comes out to 331.83, which is what we got earlier. So that's the correct answer, not choice C, which most of you are going to pick because you go too quickly. Take an extra 30 seconds, slow down, make sure your answer is in the correct format. Okay, so I know a lot of you don't like reading the question, so we can just look at the picture. I'm going to go back and read it in a second, but I can tell this is a composite figure, meaning 2 shapes together, and they're going to be added together because there's a cone on top of a cylinder. So step 1, we need to find the volume of one of the shapes. It doesn't matter which one you start with here. So I'll start with the cone because it's on top, but it doesn't really matter. We're going to find the volume of the cylinder, CYL for short, and then we're going to add those together. The hardest part of this question is that the information, the way they give it to you in the picture, you have to do a little work with first. You can't just plug these numbers into the two formulas. Some of them you can, some of them you can't. So let's take a look. The first thing we're going to do is find the volume of the cone. The volume of a cone is 1/3 times pi times radius squared times height. Well, let's see, do I have the radius? I'm looking at this circle right here, which is the same side as the circle at the bottom. They don't give me the radius, they give me the diameter. But we know that the radius is just half the diameter. Since the diameter is 4, the radius is 2. And the height of the cone, which is just this part right here, I'm not including any of this yet. The height of the cone is just 3 centimeters. Quickly, I'm going to look at my answers because I want to know what format they want it in. And it's in terms of pi. So when I go to my calculator, if I have a multi-view, I might be okay. If I don't want to put the pi in. So 1/3 times 2 squared times 3. So if you don't have a calculator that can put in fractions, here's how you do it. You put parentheses, 1 divided by 3. That's how I put in fractions. The calculator I had in high school, instead of a TI-84, was a TI-83, and it did not have a fraction button. So I had to put it in like this. So 1/3, I believe it was times 2 squared times 3. And notice I'm leaving out the pi. And it just comes out to 4. That worked nicely because the 1/3 and the 3 are multiplicative inverses of each other, so they cancel each other out. So I go back, and this one comes out to 4 pi. Now, if you did put the pi in your calculator, let me see what I can do here. I can click that, I can put the pi in. It would have come out to this, which is fine. You can deal with that later. But since the answers are in terms of pi, I think it's better to leave it in terms of pi. All right, the second step is to find the volume of the cylinder. So volume equals pi times radius squared times height. Same radius as before because it's the same circle at the bottom. So it's 2 squared. The height of the cylinder. Well, the cylinder goes from here to here. I remember this question. I remember that most of you put 10. 10 is not the height of the cylinder. 10 is the height of both shapes together. So how can I figure out how tall the cylinder is? Well, if the entire height is 10, and this little bit here is 3, what's missing from here? 7. So the height of the cylinder is 7. Again, I'm not going to put the pi in my calculator. 2 squared is 4. 4 times 7 is 28. So 28 pi. And when I add these together, 4 pi plus 28 pi, so that's the volume of the cone plus the volume of the cylinder, equals 32 pi. Choice A. Cylinder and a cone have the same volume. The cylinder has a radius of 2 inches and a height of 3 inches. The cone has a radius of 3. What's the height of the cone? Interesting, a combination of 2 types of questions. The first part is straightforward using a formula. That would be the cylinder part. The second type is looking for the missing piece of a shape. We're looking for the height of the cone. So I'm going to do this work separately. Cylinder, cone. And we're going to start with the cylinder, 1, because it comes first, and 2, because they gave you all the information for it. Volume formula for a cylinder is pi times radius squared times height. They give me the radius is 2, and they give me the height is 3. So now I have a choice here. There's no multiple choice. I can leave it in terms of pi, or I can round it to a decimal. Anytime you're dealing with a question that involves volume, that has the pi symbol in it, and it's a multi-part question, it's probably going to be easier to put it in terms of pi. You will get the same answer if you use a decimal, as long as you don't round it too early, but I'm going to do it in terms of pi. So 2 times 2 squared is 4, times 3 is 12. So the volume of the cylinder is 12 pi. So now let's take a look at the cone. The volume formula for a cone is 1/3 times pi times the radius squared times the height. Now if I start filling this in, and this is what most of you do when you go really quickly, you go pi, you go, oh, the radius is 3. I don't know the height, so h. And some of you might have taken the height from the cylinder and used it even though it doesn't say that. So it's like, oh, how can I solve this? I don't have enough information. Well, they give you one more piece of information. It says that the cylinder and the cone have the same volume. So if the volume of the cylinder is 12 pi, then the volume of the cone is also 12 pi. So I can cross out the V and replace that with 12 pi. We learned back in the volume unit how to solve this type of equation. Hold on one second. I'm just going to leave it here. We learned how to solve this type of equation, and one of the things we learned was if we would divide both sides of the equation by pi right now, the pi's would cancel out. So that was one thing we were allowed to do. And then I want to simplify 1/3 times 3 squared. I can do that in my calculator, or I can do it mathematically if you're good with that kind of stuff. I'll do it on the calculator. 1/3 times 3 squared, and it just comes out to 3. So now I have 12 equals 3h. So if I'm trying to solve for the height, all I have to do is isolate the variable, get rid of that 3. So divide both sides by 3, and I get h equals 4. So that's my final answer. H equals 4 inches. The hardest part of this was using the information that they have the same volume to put the 12 pi in the cone formula. Okay, next question here. All right, so just by looking at this, I can see that this is a more involved question. That might end up being trickier, but it does look like we have a giant cone. And the way they broke it up is there's like a smaller cone on top that is now missing. So we're going to be removing it. And when I think about that, without even reading this question, it sounds like we're going to have to find multiple things and then subtract them. If you're removing a piece of an object, you're going to have to subtract it. This object down here, it's not a cone, it's not a cylinder, it's something in between. It doesn't have a specific formula. So you have to do it in a different way. So let's take a look at this question. And this question, by the way, you had in 8th grade. This is from a state exam from 2 years ago. I've seen very similar questions, like almost the exact same thing, on the 10th grade geometry regions. So you are going to see stuff like this again. So it's good to have just like a good foundation of it now that your high school geometry teacher can build upon instead of having to reteach it. All right, the circular base of the cone below has a center C, another circle with center B. That information isn't really super important. I'm just going to point out, here's a circle, there's its center, they call it C. Here's another circle, there's a center, they call it B. Nothing crazy. The circle is the base of the smaller cone with height AB, and the measurements in the diagram are given in inches. Triangle ABD is similar to triangle ACE. That's a topic that we did all the way back in Unit 1. Similar triangles, which comes up again in high school geometry. It doesn't go away. So here is a triangle, ABD, and here is a larger triangle, ACE, and they're saying they are similar to each other. Why do we think that's going to be important here? Because similar triangles, or any shapes really, have proportional side lengths. We also learned about their angles, but this question has nothing to do with angles. So something with the side lengths is my guess. And honestly, if you didn't even remember similar figures too much, you can probably work your way through this problem anyway. So back to the question. The smaller cone is removed to create the new object. What is the volume of the new object? So we need to find the volume of the entire thing. Then we need to find the volume of the cone, and then we need to remove it by doing subtraction. The problem is we're going to have to do another step in there. So step 1 will be to find the volume of the big cone. Step 1B, and there's a 1B because we can't find the volume until we find the radius of the big cone. We have everything else, but notice where the radius is, there's an X. So we're going to have to find that. Once we find that, we can find the volume, no problem. Step 2, find the volume of the small cone. And we have all the information for that, so that won't be an issue. And then step 3, we're going to subtract because we're removing the small cone from the top of the object. We're not adding it on, we're removing it. So let me make this smaller so I have room to work. All right, so step one, we're going to find the volume of the large cone, but we can't do that until we find this radius. So I have to look at these two triangles. That's what they want me to look at. Here's ABD if I redraw it, and that's 5, and that 2. And here's ACE, the bigger triangle, the one that's from here. That one has a height, oops, I lost it, that's my fault. 2. That one has a height of 10. You could see that because it's 5 and 5, that makes 10. And it has a radius of x, or a side length of x here. Now, knowing my properties of similar triangles, that they have proportional side lengths, that means I can either set up a proportion or use a scale factor to figure out the missing side. Well, since 10 is twice the length of 5, meaning I can do times 2, I could do the same thing to the other side to find out that this missing side is 4. So this side right here is double the length of this side. And that's because they told us that they were similar. So when I was grading this exam a few years ago when we were grading the state exam, a lot of students were able to figure out that this is 4. I think a lot of them might have guessed, or just it looks like double, or 5 and 5 is double, so it must be double. But we were able to take it. They didn't have to do much there, so that's good. So now we can find the volume of the big cone. The volume formula of the cone is pi times radius squared times height. We now know that the radius is 4 and that the height is 10, not 5. A lot of students use the height of 5 here. I'm going to leave my answer in terms, actually it says rounded to the nearest tenth. So I know most of you right away will go to decimal, so I will do that as well. Remember, do not fully round your answer until the very end. So I go to my calculator and I do pi times 4 squared times 10, and I get 502.655. 502.655. So that's the big cone. Now I need to find the volume of the smaller cone. And that one I already had all the information, so we can jump right into it. Pi times radius squared times height. The radius of the smaller cone is 2. The height of the smaller cone is 5. I go to my calculator. I do pi times 2 squared times 5. And I get 62.832. So I am rounding my answers. I know I said don't round till the end, but I'm not rounding them all the way to the 10th. That I will save for later. And the third step here is to subtract. 502.655 minus 62.832. A lot of you like to jam the clear button on your calculator, or the memory cleared button on your calculator super fast. But this is why it's a good idea not to do that until you completely finish the problem, because now I can just go up to this number and use it again. Enter, minus this number, and then hit enter, and I get the exact answer, 439.823. 439.823, which to the nearest tenth is 439.8. So that is the final answer to this question. Okay, so a metal paperweight is in the shape of a cylinder. If you want to draw a picture, you could draw a very basic cylinder. The paperweight has a diameter, that's a line that goes all the way across, of 4, and a volume of 8 pi. I like to write all my information down separate from the question, again, using the solve strategy. Notice I'm not using a template. I'm not writing down S-O-L-V-E. I'm just doing it. Once you get used to solving problems this way, it actually doesn't add time. It saves you time, because now I don't have to reread this question. I know exactly what I'm looking for. I'm looking for the height. That's S. I organized my information already. I don't have to go back to the question. I don't have to read this ever again. So get used to using that strategy. Take the time now so that when you get to higher levels of math in 10th, 11th, 12th grade, and maybe even further into college or trade school or wherever you choose to go, you have these strategies in place. The volume formula of a cylinder is pi times radius squared times height. fill in the missing information. Well, we know the volume is 8 pi. We know the radius is 2 because it's half the diameter, and we're looking for the h. I notice that there is a pi on both sides, so you can divide both sides by pi. And I told my class, I don't know what the other teachers have told theirs, but you don't have to show this. You could just cross out the pi's. I'm going to move my equation over here. So now I have 8 equals 2 squared times h. 2 squared is 4, so I'm just going to write 4h. Divide both sides by 4, and I get that h equals 2. And this is another reason why it's important to sometimes have your answer in terms of pi, because if you're working backwards, you want to have the pi on both sides of the equation because it'll make your life easier. So here's 2 more questions that are similar to that one. I'm just going to do the work right on the screen. Find the radius. I'll do the first one in red so I don't mix it up. Find the radius of a cylinder whose volume is 360 pi and the height is 10. Volume equals pi times radius squared times height. 360 pi. And a lot of kids, when we learned this unit, wrote 360 but not the pi. The volume is 360 pi, not 360. Those are very different numbers. So filling in the rest of the information equals pi times radius squared. I left it as an r because that's what we're looking for, times 10. So I notice there's a pi on both sides. If I divide both sides of the equation by pi, those go away. Now if I divide both sides by 10, I get 36 equals r squared. I don't want to know r squared, I want to know r. So how do I get rid of the squared? I need to do the opposite of that. The opposite of squaring something is square root. And when you get the graphing calculator in high school, which you will, to get to the square root button, it's right above the x squared button. On the multi-view calculator and scientific calculators you have now, the square root button has its own button right here next to the x squared. Next year, it's this little colorful symbol above the x squared. So you hit second x squared, and you can see on your screen the square root symbol pops up, 36, and I hit enter, and I get 6. So the radius equals 6. The next one, again, it's a cylinder where the volume is 500 pi, the diameter is 10. So right away, that tells me the radius is 5. And we're looking for the height, so I'll put a question mark. Volume equals pi times radius squared times height. The volume is 500 pi equals pi times 5 squared times h. Since there's a pi on both sides, I can divide both sides of the equation by pi to get rid of them. So now I have 500 equals 25h. The 25 came from simplifying the 5 squared. 5 squared is 25. Divide both sides by 25, and I get h equals 20 inches. Final answer. All right, so here's another type of question that is going to be popular in high school geometry. They like to give you questions that have different units in them to try to trick you, and that's what this question does as well. So an above ground swimming pool in the shape of a cylinder. So we're not talking about in-ground ones. You've probably seen these above ground ones in movies, TV shows, or in your friends' or neighbors' backyards, but they're the ones that look like, kind of like this. It has a diameter of 16 feet. So I'm organizing my information. It has a height of 6 feet. And the pool is going to be filled with water to 12 inches from the top of the pool. This is the part that confuses most students. And I was just working with a student on geometry this past week, and they had a question that used that same terminology, filling something 12 inches or a foot from the top of the pool. So it's not filling up all the way. It's only filling up to about here. So they're filling all of this with water, but not all the way to the top. It says 12 inches from the top. 12 inches, first of all, equals 1 foot. Let's change everything to feet because that's what we're dealing with the other numbers, feet. So this little bit right here is 1 foot. The blank space is 1 foot, meaning the height of the water is 5 feet. That's going to be important. What's the volume of the water in the pool? If they wanted the volume of the pool, easy. We use the radius, which we're going to figure out. We use the height, and we're done. But they don't want the volume of the pool. They want the volume of this water. Well, the water takes the shape of a cylinder when it's filled in the pool, so we're going to use that formula. It has the same radius as the pool because it's going all the way across. The radius of the pool is 8, and the height is only 5, not 6. They did not fill it all the way to the top. They filled it 12 inches from the top. So that's where this 5 comes from. Now I just go to my calculator. It does not tell you how they want the answer, so I'm going to put it in both terms of pi and a decimal. So in terms of pi, I just do 8 squared times 5, and I get 320 pi. And if I wanted it as a decimal rounded to the nearest tenth, I would use the pi in my calculator. So pi times 8 squared times 5. Notice I didn't use parentheses here because I know exactly how the calculator works. If you're not sure, be safe and use parentheses. And you get 1005.3. Okay, and that's it. That's it for that one. The trickiest part was getting this 5. Let me see. I think this is it. This is the last question. This is also an old state exam question. And again, something I've seen. I think I might have seen this exact one on the high school geometry regions. And they like to repeat similar questions. So seeing the more you can see these questions, the better. So a box contains 9 identical glass ornaments. The spheres are tightly packed as shown below. What is the volume of all 9 spheres? Well, since they're all identical, I really just need to find the volume of one of them and then multiply it by 9. So I'm just looking for the volume of one sphere, and they give you the formula. Volume equals 4/3 pi times the radius cubed. Now the problem is I don't have the radius, but they give me the length of the box. The length of the box is 12 inches. Well, since these 3 spheres are going across the length of the box, they each must be 4 inches. 4 plus 4 plus 4 is 12. So the diameter of each one of these spheres must be 4. So if the diameter is 4, that means the radius must be 2. And that's it. Now we can use that. Volume equals 4/3 times pi times 2 to the 3rd power. And I'm going to get an answer. I'm going to use my calculator. 4/3. You can use the fraction button, or you can enter fractions like this, times pi times 2 to the 3rd power. If you don't remember how to do it to the 3rd power, you use this little caret button. It might be in a different place on your calculator, but it definitely has it. I click that, I hit 3, I arrow over so that my cursor is just at the end, and I hit enter. And I get 33.51. That's not your final answer. That's the volume of one of the spheres. But we have 9, so I multiply that by 9. So let's go back to my calculator. If I just hit times 9, look, it says answer times 9. That means the previous answer times 9. And there's another way you can enter that on your calculator now or next year. If you look down here where the negative symbol is, in little writing above it, it says answer. So I can hit second answer. So now we're taking the previous answer and timesing it by 9. And I get 301.59. So volume equals 301.59, but it says to the nearest cubic inch. Nearest cubic inch means nearest whole number. So the volume of all 9 spheres must be 302, rounded to the nearest cubic inch. And that's it. If you have questions, you have 2 days to do this assignment. Please reach out to your teachers. We are happy to respond to you just by texting back and forth on Google Classroom, or we can do a live session, which we offer once or twice every week, and we can do even more than that. If you prefer to do a one-on-one live session, request it with your teacher. I'm sure we will be willing to make that work for you. Or you can look on Google or YouTube and find good questions, good videos to watch. If you need help finding good videos, you can email us about that and we can send you good links. you could probably type in these exact questions on Google and find a video explaining them. So if you don't like this video, if it's not, for some reason you're still confused and want to hear someone else explain it, do that. Or if you want to go live and ask specific questions, do that. If you want to go live just to chat about life or school, do that. Don't get lazy now. Do your best. I know this is very frustrating. We're all feeling it, but we have less than a month left. We want to make the transition to high school as easy as possible. Good luck with everything. I hope everyone's staying busy, safe, and sane. And please reach out. I know I speak for all of the 8th grade math teachers that we miss you and wish we were in class teaching you. Have a good one.